Hello, Honors Outers. It's Mr. Lawrence here, and we're going to have a video on completing the square. What the heck is completing the square? Well, it's kind of cool, and actually it has everything to do with what we're doing right now. It may not seem so obvious at first, but trust me, after a couple examples, you're going to go, oh, this is kind of neat, and it totally applies with graphing quadratics. Now, one thing I want to mention to you is, remember back when we were factoring? Many of you had a hard time learning how to do the perfect square trinomial. Well, being able to factor a perfect square trinomial is essential to completing the square. Remember that the first term must be a perfect square. And you take the square root and you get x, right? This last term must be a perfect square. Take the square root. Now, if you multiply these two together, these two square roots, and double it, so you multiply them together, then double the answer. So it's going to be 6x. If that matches the middle term, then you've got a perfect square trinomial, and this will factor as x plus 3 quantity squared. You remember doing that? Okay, now hopefully you can go back and review if you're not sure. Now watch what we're going to do here. This problem here, we'll call this problem number 1, is definitely not a perfect square trinomial. While x squared is a perfect square, 1 is a perfect square. If I take their square roots, multiply them together, double it, I don't get 10x. But watch this. I'm going to rewrite this as x squared plus 10x, oops, 10x, there we go. I'm going to put a little blank here in the middle of the problem. I've got my plus 1, and I'm going to put another little blank here, only I'm going to put a minus blank. Okay? Still equal to 0. Now what I'm going to do is I'm going to take half of this number, okay, which is 5, right? And I'm going to square it, 25. Okay? I have just turned this part of the polynomial, this part right here, into a perfect square trinomial. Now you know you're not allowed to just add 25 to a side just because you want to. If I do it to one side, I have to do it to the other. Well, if I'm not going to actually add 25 to the right-hand side, but instead I'm going to subtract 25 from the left-hand side. See, the two 25s, one's positive, one's negative, they cancel each other out, don't they? So I haven't changed the way the problem looks. Now, I'm going to factor this as a perfect square trinomial. Well, that's going to be square root is x, square root of that is 5. There's a plus in the back. It's the Wendy's double stack. It's going to be a positive. I'm going to make the quantity squared. And then I'm going to combine these two terms right here. I'm going to combine these two terms. And what's going to happen is I will get negative 24. Okay, now you say, well, why are we doing this? Just hold on. We're going to practice it one more time. And then I'll show you why we're doing it. As you can see, we're getting down to the graph. Okay, so let's try this. We're going to write down, we'll call this problem 2. Problem number 2. All right, we're going to divide that. We're going to get x squared minus 4x plus a blank plus the 7 minus a blank equals 0. I take half of this number, which is negative 2, square it, which would be positive 4. Positive 4, I need a negative 4, and there it is. So the two 4's are canceling each other out. Now, these first 3 terms are the perfect square trinomial. X, 2, it's a negative, I square it. Combining these like terms, I get 3. That'll equal 0. Okay. All right, so you've seen what I do. Okay, now I'm going to graph this one traditionally. And so the first thing I'm going to do is going to find the discriminant. So I'm going to do b squared minus 4ac. Of course, I need a, b, c, easy as 1, 6, 8. All right, I'm going to plug this in. So I'm going to get 6 squared minus 4 times 1 times 8. I'm going to get 36 minus 32, which is equal to 4, which is cool because I'm going to have two solutions or two roots, right? Okay, so now I'm going to go x equals the negative of b plus or minus the square root of the discriminant all over 2a. All right, so I'm going to simplify this, get negative 6 plus or minus 2 over 2. And then x is going to equal negative 6 minus 2 over 2, which is negative 4. And I'll also get x equals negative 6 plus 2 over 2, which I believe will be negative 2. So my two roots are at negative 4, 0 and negative 2, 0, right? Okay. Now I'm going to go looking for the vertex, and I'm going to do x equals the negative of b over 2a, which will be negative 6 over 2, which is negative 3. So my line of symmetry is x equals negative 3. It's a vertical line, right? Going right along here. I know this parabola is going to open upward because a is positive. So that's just my line of symmetry there. And now I'm going to plug negative 3 in here. Okay, so I'm going to get y equals negative 3 squared plus 6 times negative 3 plus 8. That'll be 9 minus 18, which is negative 9, plus 8 is negative 1. So the vertex occurs there. The vertex is at negative 3, negative 1, right? Okay, now you're thinking, Mr. Lawrence, what the heck are you doing? You showed us this completing square thing, and then you went ahead and did a problem that we already know how to do. Well, check this out. I'm going to erase this work. There's nothing wrong with my work. I'm just erasing it just to get it out of my way. And I'm going to do the completing square, the square trick on this equation here, the y equals x squared plus 6x. So I'm going to go y equals x squared plus 6x plus blank plus 8 minus blank, right? Okay, I'm going to take half of the 6, square it, get 9. Then I've got to subtract 9, right? So now I can do the perfect square trinomial thing on these first three terms. I'm going to get y equals the quantity of x plus 3 squared, and I'm going to combine those like terms and get a negative 1. Now, if you remember just a few minutes ago, I found my vertex was negative 3, negative 1. Hey, look at this. A negative 1. Coincidence? I think not. And then this, x plus 3 equals 0. Subtract 3 from both sides, and x equals negative 3. Wow. This completing the square thing can tell me the coordinates of the vertex without plugging in the number like I did. It's pretty easy, isn't it? Let's try another one. Tell you what, let's go ahead and we'll find the discriminant. A, B, C. Easy as 1, negative 10, 2. All right, so I'll do b squared minus 4ac. That'll be 100 minus 8c which is 92. So there's going to be two solutions, right? And so I'm going to go x equals the negative of b plus or minus the square root. Ah! Not sure what number that was, but it should have been a 92. All over 2a. And so I'm going to get two answers. X is going to be approximately. Now hold on one second here. Let me get my calculator up and running. Okay, so let me plug this in. I've got 10 plus the square root of 92. And I'm going to divide it by 2. And so I get about 9.80 if I round that, right? So one of the roots, where are you? Oops. 9.8. Okay. And now I've got to do the same thing, but with the minus, right? All right, hold on a second. Second enter. Go over and edit that plus to a minus. And there we go. We get about a 0.20. 0.2. 0.2. Okay, very good. So, let me come back here. Come in, get big. There you go. Oops, wrong place. All right, so 9 8/10 would be about there, right? And that would be there, right? Okay, now let's go ahead and find the vertex. Now, if I do the negative b over 2a, I can do that, and it won't be too bad. It looks like the x-coordinate of the vertex would be 10 over 2, which is 5, right? And then I'd plug 5 in. I'm going to get 25 minus 50, which is going to be a negative 25 plus 2. It's going to be a negative 23. Okay, well, let's do the completing square thing and see if I get 5, negative 23. Because if I do, this is pretty cool. All right, so let's try this. So y is going to equal x squared minus 10x plus blank plus 2 minus blank. All right, so half of that will be negative 5. Squared will be plus 25. So we need a minus 25 there. I can complete the square on the first part and get y equals, I'm sorry, do the perfect square trinomial, x minus 5 quantity squared minus 23. Hey, what makes this 0? When x is 5. What number is that? A negative 23, and there you go. All right, I guess I could count by 3s ought to work. So let's see, 1, 2, 3, 4, 5, and I'll count by 3s going down. It's 3, 6, 9, 12, 15, 18, 21, 24. So it's going to be right about there. And I'm going to let you go ahead and draw it in there because, oh, hey, that might be the best one I've done ever. All right, here I was doubting my ability. I think everybody for my ability to clone and flip, because this is going to be the best looking parabola I think I've ever done. Oh no, I lost everything. Got the wrong piece. Let's see, there we go there. That's going to be probably the best looking parabola I've ever done using the airliner. All right, that's it for tonight's video, completing the square and how it helps us find the vertex. Pretty nifty stuff if you ask me. All right, Mr. Lawrence signing off. Have a good night, everybody.